All right, well, welcome everyone to our Succeed with LEED series. And in this case, we're focusing on the electrification as our topic. The Succeed with LEED series offers a way to understand the LEED rating system through the lens of a particular construction, design, operations, and sustainability strategy. The series highlights prerequisites and credits available within a given topic on how to achieve them, document them, and what to look out for. While many topics will apply to all LEED rating systems, we mostly focus on the LEED residential system for single-family, multifamily, mid-rise, high-rise, and mixed-use buildings. The series mostly considers new construction or gut renovations under V4 and V4.1, but can be beneficial to home improvement plans and processes that are even smaller than full renovations or gut rehabs. Now, whether you're doing an alternative green building certification or just looking for tips on building more sustainable, you do not have to be focused on LEED to be benefiting from this conversation. So we'll be covering many topics over time in our Succeed with LEED series, and you'll be able to reference all those on one playlist. If you have any ideas for topics that you want us to cover that you're trying to explore on a LEED project, please let us know in the comments and the surveys, and we'll take a look at covering those. Before we get started, a quick reminder, this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team of 3, and actually our program manager, Eliza here, will be assisting you if you are looking to actually work on LEED projects with us. This course is approved for multiple continuing education units. Got a few too many logos in the middle there, forgot to remove them, but it's approved for the Certified Green Home Professional designation in health and energy only, as well as AIA, submitted for AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license, and submitted for Passive House Institute FIA-CUs as well. So this particular Succeed with LEED series is going to focus on the benefits and drawbacks and what you need to know when you're considering electrification within a LEED project, within a green building project, and then general awareness and education around electrification and what the benefits and opportunities and concerns are. So what do we mean when we talk about electrification? Well, let's first look at probably the most concerning one is heating and cooling, especially in cold weather climates, using heat pump technology. So we've done a lot of sessions on heat pumps. So if you want to know more about those, you can go back to those sessions. But consider ground source versus air source, ground source being geothermal energy. So those are considerations. Then considering air to water, water to water, water to air, or some other combination. And then also you might need to consider radiant systems versus ducted systems versus just mini splits, or even ducted mini split systems, or again, even some sort of combination between them. What about variable refrigerant flow, VRF systems? That's on the heating side. Now, on the water heating side, you may consider heat pumps versus electric resistance, which is what we'll be talking about. And sometimes solar water heating, which is still, very rarely used anymore. For cooking, we'll be considering within the LEED aspects, all electric cooking versus resistance versus induction. For dryers, considering electric versus heat pump, and whether that includes condensing, as most are condensing in these instances. And lastly, let's consider vehicle charging, which is part of the electrification conversation, and how that's going to play into LEED certification. Now, here are all of the different items we'll be referencing. You've been given a handout. In that handout, it has direct links for further information on how to achieve each of these. If you see the P before it, we're talking about a prerequisite, something that is mandatory, something that you have to do. If you're looking at a C, you're looking at a credit. That's an opportunity. You gain points in LEED through credits and achieve higher levels of sustainability with those points. 40 being certified, 50 being silver, 60 being gold, and 80 being platinum. So electrification is going to give you points, and we'll point out how that's being done. So in your handout, you can see all those and link back to those. Also, we'll be discussing the project phases of a construction project and how it relates to LEED and where each of these electrification items come into play. Now, most of these items will come into play in all the phases, but there will be specific phases where certain aspects of them we'll be discussing. So right now, we'll be focused on the early planning and design phase. Where does electrification need to be part of that conversation when you're doing a LEED project to make sure it is successful in that early design phase? So every LEED project requires a preliminary rating, which requires a planned target for the LEED level, selected credits, and who is going to be responsible for achieving those credits. Electrification should be embedded throughout the preliminary planning process to be successful. The team needs to get the preliminary rating down effectively and make sure electrification is both accepted within that rating and implemented within the rating as well. The preliminary rating includes an integrative process, and this can bring additional points and make sure electrification implementation is successful. Everything begins in the design stage, and you're going to hear me repeat this throughout this session, all of our LEED sessions, anytime we do a LEED session. The fact of the matter is, if you get the design wrong, it makes LEED harder and harder to achieve, and we've found it makes electrification disappear. It goes away, and next thing you know, it hasn't been achieved either. So it's very key to get it right in the design stage. When assembling the team, you can get different points of view for having diverse, you can get more points for having different diverse skill sets as listed here on your team, which are going to help drive electrification forward and ensure buy-in. For electrification, we're primarily going to be talking about the electrician, the mechanical, MEP, HVAC, call them what you will, plumbing contractor, and then maybe you're going to be bringing in an appliance specialist into the conversation as well. Design or former architectural needs to be involved in this conversation always, and needs to help ensure that the parties are well connected. Solar design used for renewable energy, which is going to help proper sizing of your renewable energy system. The size of your renewable energy system will maybe change depending on the electrification goals of your project. So you might need that renewable energy expert at the table to have that conversation if you're planning to have them involved. The initial design meeting, what's going to happen? What are the technologies being proposed? That's a conversation you'll have at that design meeting. How do those technologies work together? Is power demand going to be a concern? What is the preliminary energy rating telling us when we're using electrification? And then we have ongoing team meetings that need to occur to achieve the LEED integrative project team management process. And so where electrification plays into those team meetings is key to ensure its success. That includes maybe having that design charrette, which ensures in-depth communication between those team members I've listed, and being able to explain what everybody needs to know and how they can learn from each other during that time. So let's talk about some of these special skill sets who are going to be engaged, hopefully, during that integrative design process, which again, we hope you'll utilize on your LEED projects, not only to score the additional 2 points, but to make sure LEED and electrification are implemented properly. Now, the electrician needs to size the electrical panel and the loads properly on the house and help determine how it's going to function with the utility company, the neighborhood. Is the transformer in the community big enough to handle the electrical load? The electrician also being involved in the LEED design charrette and integrative team meeting, we'll work with the designer to locate any electric car charging infrastructure, whether it be in the garage or outside or in a multifamily parking lot. Where are those electric car charging infrastructures going? That's a conversation. You don't want to just design the building and then slam it in later. It's going to make or break that. Now, during the LEED integrative design meeting, the HVAC is going to play a key role in electrification because especially in cold weather climates on the heating side, the HVAC first needs to be on board with the idea. Did you hire an HVAC who's showing up to this design meeting totally opposed to it? That's fine, but how do we use that design charrette time to bring them on board with electrification? They're a good HVAC contractor. You want to work with them, but they're not on board with electrification. Do you need to hire someone else? I don't know. That's part of that design meeting. So the HVAC needs to be on board in supporting this strategy. They may need to learn about heat pump technologies during the charrette and how it works. Make sure that they're on board and getting the proper training that they need and working with the builder and the rater to determine the proper sizing of the heating and cooling system and where its placing is going to be. Also, they need to determine which systems make the most sense. As I mentioned, so many different systems: ground source, ducted, ductless, air to water, ducted mini splits, just to name a few. And a combination. How do they impact the energy score? What is the cost to doing this? And do they need to communicate with the civil, right? For the outdoor landscaping. If you're doing ground source heat pumps, where's that drilling going, right? Is it destroying landscaping? Where is that exterior heat pump condenser going? They're having these conversations during the design charrette to ensure electrification can be successful. Where are the refrigerant lines running? If you're using VRF for mini splits, how are they accessible? How are they maintained? These are all important questions to be asked. Now, also during the LEED integrative design meetings and LEED design charrettes, the plumber needs to be engaged. They need to be working with that architect to place the water heater, especially if it's a heat pump water heater, in a proper place to get its airflow and not impact the adjacent spaces for occupant comfort. They need to work with the electrician to get the proper electrical panels in place, unless they're using 120-volt water heaters, which may only require traditional electric lines. Maybe that's the conversation that you have during that design meeting in the context of achieving the LEED certification. And how does that impact the energy modeling? This needs to be communicated in regards to, operation costs as well. The plumber also needs to be working with that appliance specialist I brought up and looking at condensing dryers and where that's going to be plumbed and how it's going to be properly plumbed and maintained if they're using, heat pump condensing dryers. Again, refrigerant line placements, ducted versus ducted mini splits, and bringing in, lastly, that appliance specialist, something that you don't always have on a team. But I think that's really key for electrification, because one of the other biggest barriers to electrification is the client on board with cooking, not using methane or propane gas, fossil gas. Do they want to use induction? How do you, if they're not on board with that, how do you educate them about induction? A lot of times we find in the LEED process, and they want to go all electric, but the client's really nervous about the cooking side of things. So once you get the heating side of things out of the way, if the client's nervous about that, we've seen projects, sadly, all electric, but then bring in one little gas line just for the cooking. And so in those cases, having that conversation early with the client in the design team meeting, in the design charrette, hey, let's do a cooking demonstration during this design meeting. Here's how induction will work well for you, right? Get that appliance specialist to sell it to them so you can eliminate that gas line and be a true all-electric project, which benefits LEED. You also need to talk to the appliance specialist about power draw, power loads, and what the systems that you're going to be using what those will be drawing and having those connected with the electrician. What are the incentives available for those? And what is the maintenance and upkeep and warranties of all these different systems? Everyone has those concerns. They're different systems. So discuss them during the design charrette meeting. It brings a little bit of a different conversation to the integrative design process. Now, after having the big design meeting, these specialists need to continue. These specialists need to continue having these monthly meetings, right? As design finishes, wraps up, gets to 100%, and as construction starts. So part of the required LEED integrative process is not just the initial design, but the ongoing communication between the team members and the green rater and the provider and the client. What ends up happening? Design change orders, right? They can't find a product, so they put in a gas product. We've seen that happen a lot. There are supply chain issues or cost considerations. These things happen during the build time, so we need to stay in communication with the entire team. Hey, we're making this change order. How does it affect the electrification? Hey, we don't have enough on the electric load to make that change. We need to upsize the line, right? Have that communication. We just had a project where there was a communication breakdown and the electrician installed the wrong wiring for something. And so that didn't get identified during the ongoing communications. And so we found it during the final inspection when the green rater and the energy rating did the inspection. But the electrician had to go back and, swap some stuff, some different appliances out, different switches out, short of having to go back and rewire, which would have required tearing out the drywall. So they had a deficient system installed because of that. So that could have been caught, perhaps, if there were these ongoing communications. Hey, what are you installing here? Does it work for the system we spec'd? No, it doesn't. Well, you did the first unit wrong. You can fix that one. We got 50 more units to go on a multifamily. Then it's too late. So these are all important. So as I mentioned, not all HVAC and mechanical plumbing are on board with electrification. And even if the supervisor of each trade is on board with it, it doesn't mean the actual contractors in the field are supportive of the efforts or knowledgeable of the efforts. So that's why the trades training, which is an additional point under the LEED integrative process point, is so big for the electrification movement in my mind. This credit is an opportunity to spend time training individuals on the importance of heat pump technology, induction cooking, wiring processes. And it's beneficial to properly install and commission these systems accurately so they function well and there's not complaints later. And, this must occur after the trades are hired, but before construction begins per LEED. So it creates a bit of a chicken or the egg scenario in regards to LEED. And I don't know if they'll fix that in the new version, because you have to sort of have it happen before the project starts, but not after the project starts. And so it's this void of a time that never exists. I kind of joke a little bit, but it's really that sweet spot. If you what we say, white box out a couple of units, right? Finish. If it's just one home, you have to train on that one single family home. So the whole single family home becomes one training initiative, which I think some of you are doing, and I appreciate that, and that's really cool. But if you're doing multifamily or a neighborhood, finish one or two units first, or finish one of the homes in the neighborhood first, and use that as your training center and train your teams on that home and get it right. And then make sure you're using the same teams, which I know there's lots of turnover in the industry. That's tough. But you have to be using the same contractors and getting them trained, and on those next homes that come out. And this, whether you're doing electrification or not, this is a great strategy to use to make sure you hit the sustainability targets of LEED or any green program. But very key to make sure you're installing heat pump technology and commissioning it correctly. Do it first on the first unit in the first home, and then proceed to build the rest when you find that they're in good shape. All right, so moving on from sort of that early planning and initial design stage into sort of the plan review process and initial construction stage. So in this one, we're looking at the prerequisite energy and atmosphere minimum energy performance. So we're going to spend a lot of time on this one. This one is key for electrification, and you'll find electrification highly benefits this one. So this credit prerequisite has 3 components to it. Number 1, achieve the requirements of Energy Star for homes certification, multifamily new construction Energy Star, or mid-high-rise Energy Star, whichever program you're using. Now, if you're using V4.1 multifamily outside of the United States, that's a little bit of a difference, but you're still meeting a lot of these same standards. So that's number 1. You don't actually have to certify for the most part, but you do need to achieve the requirements, all the requirements of Energy Star. But if you certify, there's Inflation Reduction Act tax credits. So might as well get those. Next, part of achieving the Energy Star certification is getting an energy rating index or HERS rating. They're the same, pretty much. They're the same, but not the same. But today's not the day to go into that. Of around a 70. That's your target. Now that floats a little bit up and down, but your target is to hit a 70 on that energy rating label, which is going to help you achieve Energy Star. And then lastly, you need to make sure that your ducts are fully ducted and not panned into the joist, like in this photo here of a failed LEED project. We had to fail it. They did it all wrong. And even if you're all electric and you pan your ducts in the joist, bravo, you have a super all electric home with terrible air distribution. So you've done it wrong and you can't certify. So now Energy Star has these checklists. And where does electrification come into play? Well, number 1 is duct quality installation, right? So if you do mini split systems or ducted mini split systems, you don't really have to worry about duct quality installation because mini splits have no ducts. So one benefit to doing electrification mini split, ductless mini split systems is that you eliminate the headache of the rater and everyone having to do all this review. And we've heard of some raters giving you discounts if they don't have to deal with this stuff. In other cases, if you do a ducted mini split and you have short runs, I think, under 10 feet, then we're not so much as worried about duct leakage. You still want to do it right, but we're not worried about it. So it gets kind of thrown out. Plus, on this National Energy Rater field checklist, you have combustion appliances. And so with the combustion appliances, again, if you're all electric, toss that out. Don't even have to mess with it. The other part of Energy Star is the National HVAC Design Report. So during that preliminary integrative design process, meaning you're asking your HVAC hopefully to show up or come to the second part of the meeting with this design report completed for each unique system if you're doing multifamily or multiple housing or just one home. And so they're going to fill out this design report. They're going to design the system. And once again, if you're doing ducted mini splits or ductless mini splits, you're going to eliminate the whole duct design approach. And that's just wiped out. And one more thing you don't have to worry about from that aspect of electrification. Still have to do it with ducted air source heat pump systems. Or if you're doing radiant systems, chuck that out too. Air to water radiant systems, you can throw it out. The other thing you have to remember, though, is you got to make sure you've got your sizing appropriate, which does have heat pump considerations. Lastly, and this is jumping ahead to the final construction stage, but this is another Energy Star checklist we need to meet the LEED EA minimum energy performance. We are looking at having a proper refrigerant charge test be done. And depending on whose devices you select, a lot of this charge testing is done in the factory, so it might eliminate some of those things that need to be done during the commissioning process. So that's just another consideration. Now, one thing I want to tip you off to, as of this recording, very good timing, Energy Star is releasing their next-gen certified home. So this is basically all electric certified Energy Star homes. At this time, LEED is not requiring anything like that, but it gives you some guidelines on electrification and Energy Star, which is a requirement for LEED. And if you're going LEED and all electric, it gives you and your teams a certification that gives you that Energy Star zero electrification certification called Next Gen. So we'll be doing some more education and training around that. But I wanted to kind of tip you off to this. It kind of highlights all the things we're talking about here but in the context of the Energy Star program. And there is a chance LEED may, adopt something like this under LEED v5, which we'll talk about, here in a little bit. All right, so let's get into our case study home for this program. So we took a 6-unit single-family attached townhome in climate zone 5A in Michigan. And I have the energy efficiency features listed in the case study, so hopefully you have that and you can reference them, but I'm going to rattle them off here. This was a LEED certified project recently under V4.1, LEED single family housing, 2,024 square feet, 3-bedroom, and this is per unit. 96% efficient methane gas furnaces, 13 SEER AC, methane gas, 40 gallons, 72% efficient water heater, duct sealed combustion, 68 CFM on the duct leakage, 88 CFM exhaust only bath fans for ventilation, R50 roof, R20 above grade walls, R13 foundation walls, R10 slab, U value 0.33 on the windows, 2.44 air changes per hour on the blower door, all LED lighting, methane gas cooking, methane gas drying, Energy Star rated appliances. So this is what we're talking about. So here we're talking about the credit annual energy use. So once you've achieved your minimum energy performance in LEED, now you can move on to trying to achieve your points. And so this particular project, scored some points using these energy efficiency strategies talked about. It wasn't all electric, but what we want to do is, we rescored this home pretending that it did go all electric to see how it would have scored with all things being equal, the building shell, the envelope, the ventilation systems, but just switching the gas systems over to electric systems. How would that have scored and thus improved or decreased the energy efficiency of the annual energy use and thus harmed or hurt the LEED score on a LEED project that's using electrification? So how did they do? So here on this next slide, I want to show you the first scenario up here. This is looking at the methane gas powered home as I showed you, achieving an energy rating index of 55. Now, for those of you following energy code law in the state of Michigan, we are looking to advance to 2021 code, and so are many other states. And in climate zone 5A, where we're at, I believe 2021 code requires we hit a 52 on the energy rating index. So even this set of homes here is just barely not complying with the new code. So they would even have to do something now to build a project like this, even legally, in Michigan, assuming we adopt that new code. We haven't yet, but it looks like we will, or any other state following 2021. So how did they do? So energy and atmosphere under V4.1, this project scored 24 points. Now, put that into context. You need 40 points to certify in LEED, just to certify, and they got silver, so they needed 50 points. So just by doing, what they did, they made it nearly halfway to their goal of LEED silver. By using, traditional construction, beating our current energy code and using methane gas, heating and cooking and water heating appliances. So then we went in and said, well, what would happen if an HVAC contractor came on this project and proposed a traditional heat pump system? The HVAC contractor would come in most likely, and they would propose putting in well, first let me back up. So the other thing we did was we took the same project in the energy rating modeling software, and we ran heat pump water heater, which is a pretty easy swap out. There's usually not much resistance to that. An electric stove and an electric resistant condensing dryer, not even a heat pump. But then also we got your traditional HVAC contractor in Michigan and the Midwest who would come on and they would say, okay, we'll do a heat pump. We'll put in a heat pump. It'll work until about 40 degrees. And then a backup resistance heater will kick in after that. So what would happen if we did that on this particular project? Well, what had happened was in our scenario modeling, it bumped the energy rating index up to 66. So they went backwards, right? Higher, worse, right? More, less energy, right? Net zero over here, bad energy use over here. So home went up 11 points and, would have made them still compliant with LEED at that 70 goal, but not so great. So let's say now, same thing. We had all of those electric appliances still in place, still the same building shell, still the same items. But then we talked the HVAC contractor during the LEED integrated design meeting into using an Energy Star certified cold weather climate heat pump, which could bring it down to 13 degrees, -13, until the backup strip resistance heater. And what I forgot to say is, yeah, it dropped their points down to 15 energy and atmosphere points when we ran this in the LEED model. So anyway, when we looked at the cold weather climate, we got an energy rating index of 40, and that gave them 28 points. So 4 more points than the fossil gas system, and about 13 more points than the non-cold weather climate heat pump system. So not a huge bump up from the fossil gas system. And maybe that's, part of the LEED scale needs to be looked at. But, 28 more points, that gets them, only 12 more points they need to certify if you don't consider any other certification strategies, just by going all electric and using a cold weather climate air source heat pump system. It should also be known 40 gets you pretty close, if not compliant, with the Zero Energy Ready certification program, which can help bring, up to $5,000 of Inflation Reduction Act tax credits. So here it is again, looking at the LEED checklist. So here's the home that we certified, the HERS index option 2 being used with methane gas, and what it looks like when you're inserting the energy data under the EA credit annual energy use. And here we are with the cold weather climate, again, 28 points, and what it looks like making that update within the checklist. The other factor is the LEED energy budget. So you have to produce a LEED energy budget, which is basically looking at a baseline home. So when you do an all-electric home, your baseline becomes an all-electric resistance heated home. So up here, we looked at the LEED energy budget that was pulled for the certified LEED silver home case study, 36% more efficient than the LEED reference home. But then we looked at this same home when we did all electric cold weather climate, and it's 44% more efficient. And if you plug that into the LEED V4.1 scoring tool, we actually achieved 29 points. So when you're going all electric, and especially when you're going solar, we'll find a lot of times using this LEED energy budget gets you more points, right? This is 29 points here, but it's only it's only 28 points using the energy rating index approach. So you got to look at both of those approaches. Have your rater pull that LEED energy budget, and you might find that you're, in some cases, 1 point. We've seen other projects score quite a bit more points using the LEED energy budget, especially again when they're using solar power. But even when they're all electric, we've seen projects doing that. So make sure you're looking at both the energy rating index option 1 and the LEED energy budget. The LEED energy budget doesn't, look so favorable, and it doesn't usually work out when you're only doing a methane gas home without solar. Now, going back to the LEED energy and atmosphere minimum performance for a second, what's important to know is if you're doing a renovation, you only need to hit 80 on the energy rating index. So as you can see, just going from a methane gas, mostly gas home to all electric cold weather climate, that's a 15-point jump. So we have seen instances where it has been difficult to convince the builders to change the building shell, and especially to change the building shell in a renovation. If it's not a full gut renovation, it can be very difficult. You don't necessarily have to gut the walls to go LEED. You just need to achieve this 80 bare minimum. So let's say you found an existing home that was at 120 or 110. As you could see, by going from gas to electric with cold weather, that is, in at least in our climate. If you're not in a cold weather state, it's not going to be a problem. But in that case, that was a 15-point drop on the energy rating index. So all things being equal, if you can't really mess around with the building shell very much, you can hit this target by going all electric. So we think for LEED renovations, going all electric is going to be huge. And this works for multifamily housing and midrise. And on that note, I just wanted to say, if you're doing a midrise project, you're probably using ASHRAE 90.1. Or if you're in another country, you might be using a whole nother rating system. What's important to remember is that this logic of these energy savings drop also play out, nearly the same in ASHRAE 90.1. So if you're modeling an ASHRAE, a percent better in ASHRAE 90.1 for your midrise project, you're going to see clear benefits by switching to cold weather climate air source and going all electric within that same sort of improvement. But the energy rating index, that can be used on single family and multifamily, and it can be used on multifamily new construction of any size or magnitude. So I just use that as my energy reference, but it would be the same on 90.1 too. All right. So most of the other items we're going to be talking about are going to be a lot quicker. Like I said, your biggest impact with electrification are the items we just discussed. And they're in the early planning and design stage with that integrative design process, that design charrette, that trades training, and then doing the proper minimum energy performance and energy modeling, and having that get done correctly. If you can do that all correctly, you're headed in the right direction as construction starts to pick up. There's going to be less and less problems you need to deal with, rather than trying to superimpose, like I've done with projects before. They told me the design is completed and construction is under the way, and then we're trying to superimpose electrification onto the LEED project. We were minimal success, but most times it's just it was a waste of time. It was unsuccessful to ram these things in later on. So let's start getting into, the construction process and, what it's going to look like. So at some point, you're hiring your HVAC contractor, and then they're determining who's going to be showing up to the site and actually doing the work. If those individuals, one thing I want to point out, have a credential under NATE or the Energy Star program, they're good. They get an extra point in the rating system. Now, the downside is most of those trainings as of today do not train anyone on electrification. They're just trying to train them on better HVAC systems, but not electrification. So that is one of the sad parts of this, and I wanted to bring that up. You might think, oh, HVAC credential from the EPA. No, it doesn't really has nothing to do with electrification, sadly. So if you thought that was a good thing, it has a lot to do with better HVAC performance, but not with electrification. But that is where this comes in. And so what's happening now is there is another pathway to do your HVAC commissioning. And that commissioning can be done now by the LEED Green Rater or Energy Rater. So we've gotten staunch resistance from the HVAC from wanting to get credentialed and certified. So the EPA's response was, fine. As long as you get trained and understand how to do things appropriately, we'll have the heating and cooling contract, or the rater, come and do the minimum verification and measurements and proper commissioning of the HVAC system. We've done a session on this before, so you can all access this on our channel. But you can gain potentially 6 to 8 more energy points by doing this on the project, and it's going to make sure better commissioning of heat pump technology to make sure it works better. And they're coming out with ways to commission ground source heat pumps and mini splits as well. It's not out quite yet, but they are. So that's just going to mean better functioning systems if they have that. In the meantime, the one of the other benefits is they're not looking at full commissioning of the mini split systems. And so a lot of that can be ignored and glossed over. Some ways that's a benefit because it's less work the HVAC has to do. In other ways, it's a detriment because you want to make sure it's done appropriately. Also, you need to know the refrigerant management. This is another place where you get basically a giveaway because it's nearly impossible to get a heat pump system that doesn't at least have R410A in it. So basically, by doing heat pumps, you're having R410A refrigerant in the system, or some better, more sustainable, less global warming potential. Now, as of the end of next year, R410A is being phased out, and they're going in exchange for R452, which also is on the refrigerant list for this LEED credit. So in some ways, LEED is not leading on this one. And we think that during version 5, maybe they will fix that. And I will get to that later. But this is a giveaway point on V4.1. When you're doing heat pumps, it's pretty much, unless you're trying to purchase the worst heat pump out there, some kind of sketchy heat pump that you get for a good deal, watch out. You won't get this point then. Now, here's another one that has a lot to do with better HVAC performance as well. And this one actually fits under the environmental quality category of the balancing and heating cooling system within LEED. So this is less energy efficiency and more comfort and health for you and your clients within the project. And so if you pull open this credit and look at it, you'll see there's lots of different options, especially under the V4.1 version of this credit. So the ones I'm focusing on right now are the multiple zoning. So if you're doing mini splits and you do more than one head, you're already meeting multiple zoning for the project. So again, you can, as you can see, not only are we talking about benefits to electrification, but you can see there's multiple benefits to doing mini split systems. However, there are concerns with mini split systems. They don't dehumidify as well. And there is an alarm bell being raised about them. And even some air source heat pump systems that are ducted and really efficient don't dehumidify that well. And so LEED has given you an option for moisture load control to get additional points for ensuring you have, as we have in this picture here from one of our LEED projects we'll be doing a video tour of soon. I'm very excited to share that with you. Whole home dehumidification. So that's ensuring that the humidity issues that your clients are perhaps going to face with mini splits or air source heat pump technology, and any home, even gas fired homes, not done right, are going to have humidity issues. Having that supplemental dehumidification and moisture control is a benefit. Also under option 6, there's another 2 LEED bonus points you can get for having multi-stage equipment. Again, if you're using the best of the best air source heat pumps, you're going to have multiple stages. It's just going to come with it. There are single stage air source heat pump systems. Those typically, are less efficient anyway. So they're not going to work out in your energy ratings. And then lastly, option 8 within that one is quiet heating and cooling systems. So a lot of this air source heat pump technology and ground source heat pump technology typically is coming with lower decibel outputs. And so that bottom right picture you see, I skipped one, but anyway, I'll go back up. The bottom right picture you see is me on site testing a project that's clearly failing, of having, their HVAC system running and trying to get them down to proper decibel rating within the living room and bedrooms. And so a lot of the heat pump systems now, especially the higher efficient ones and inverter driven ones, are going to be much quieter. And so you can also pick up this additional point. And, having quieter systems are good for occupant comfort and health. And there's evidence that show, anxiety and stress and even heart-related issues can occur from sound problems. So very important. So I skipped option 7 on accident. Static pressure testing of ducts is very important. It's part of this program here, very important. But if you get rid of the ducts, you have no static pressure to test, no static resistance. So therefore, you automatically get that point. It's another giveaway when you're doing electrification and ductless systems. All right. Combustion venting, we're not going to spend too much time on this one, but this is a big one. This is a giveaway. So if you're doing all electric, this one is automatically met, because a lot of times we'll find unsealed combustion systems getting installed even in LEED projects, and that will fail the LEED project. It's got to get torn out, like the one on the left there. So when you have a heat pump or resistance electric, there's no combustion on site. So you automatically get it. It's a win. And down at the bottom right, there's an innovation credit called demand response. And so if you're using heat pump technology for the water heating, these systems can be pre-designed to be responsive to grid demands. So they heat water when the grid has additional energy, and there's not risk of a blackout during a heat wave. And then they stop heating water and they store it like a battery when the grid is at risk. And so they're pre-designed for these demand response systems. I have one. I go in and it's like, your utility currently doesn't offer this. But if they do offer it, there is this innovation credit. And this credit, to be sure, goes way beyond water heating. But this is just one of the components, which is a 2-for-1. Again, no combustion, no venting needed. Number 2, demand response with the heat pump technology. And you can see the dual multi-pronged benefits. Now on this one, this is enhanced combustion venting. And I had a little video, but with a short on time, I'm just going to share the video so you can watch it, whenever you want. But I actually walked into a LEED home. It's that top one up there. Quite a while ago, we filmed the whole home, and I walked in and I saw a fireplace, and I'm like, there's a fireplace. Nothing of it. Thought nothing of it. And this guy's like, this is an electric fireplace. I'm like, what? I see the steam. I see the smoke. I see some flames. And he's just like, yeah, it's all electric. And I'm like, this is crazy. And this was 6 years ago. So since then, there's been a lot of innovation. So if your clients want a fireplace, try to talk them into going all electric. It's an instant 2 points in the LEED rating system to either have no fireplace. That's not fun. Why not do an electric fireplace? There's also these built-in electric fireplaces. They make the noise, they have the sound, they have the light, they even have the heat if you want it, in the wintertime. Or you can just put the fireplace on the TV, right? They have the Yule logs, right? I was using one the other day. It was really fun with a Halloween backdrop to it. And you just hit play and you've got this big TV with a nice fireplace, no combustion, right? Someone recorded it somewhere else. So they had all the combustion. You're perfectly safe and your client's safe. And we know that recent studies coming out from the EPA show that people living with indoor fire, wood burning stoves especially, have massive increases in lung cancer risk. And so it's just not safe. So 2 extra credits, you get the ambiance, you get the feeling, you get the sound. Try to consider some sort of an electrification approach to your fireplace for LEED enhanced combustion ventilation. So when you're doing electric, the cool thing is about that is electric is much easier to meter and monitor than methane gas and propane gas. It's not easy, right? It's just not. They're coming out with solutions to try to monitor it in real time, and that might be helpful to detect gas leaks, which is great. But in reality it's just so difficult. So one of the simplest things for the LEED rater is that they first just have to confirm that there are meters on site. So if they're just looking for electric meters, it makes the LEED rater's job easier just to take a photo of the electric meter and not have to go find the gas meter. So that's easy, right? And then second to that is the advanced utility tracking. So again, if you're using something like Energy Star Portfolio Manager or one of the other options there, you can get additional points. Sometimes you can get even a regional priority credit on your project by just uploading the data and sharing it with USGBC. And, uploading data is an administrative paperwork headache. So again, now you're not tracking down gas data. You can just upload all the electric data and not have to try to look at both gas and electric by going all electric. It's just one more data point you don't have to deal with. And it helps you track data better and share data a lot better. But then lastly, there is this innovation credit called real-time energy submetering and real-time usage data. And that's where the fun is. And so again, getting real-time gas data, very hard, but getting real-time electric data and down to the plug load, that's probably something you and your clients will want to do. And there are some cheap systems out there that you can just plug right into the electric box, and it will give you snapshots of each electrical system in the house, how much energy it's using, when it's using it, to help the clients make informed decisions on how to save energy and be more efficient. And again, if there are gas systems, you won't get that data. You'll have no clue what's going on. You get it a month later when you get the utility bill. So it really just gets left out and doesn't become a benefit. Now let's switch gears here a little bit to LEED operation and maintenance. So LEED O&M, this is actually going to be the first foray of LEED v5, which I'm excited about. Imagine transforming all of our existing building stocks to green, sustainable strategies, and LEED is putting together pathways on how to measure that. So unlike LEED for homes, you have to get a rating done, which is what you hope will happen. This is make or break, right? This is, you actually have to achieve performance. So that Energy Star portfolio manager I was talking about is step one in the right direction to start measuring your ongoing electric use and report it. And then it will give you greenhouse gas emission scores, and it has inputs for all these data. And then you can input that data into the ARC platform for LEED, and you can get your LEED existing buildings operation and maintenance. Now, again, there is no doubt in my mind that buildings that are all electric are going to have reduced greenhouse gas emissions. Even in cold weather, high cold grids like where I'm from, we're still finding massive greenhouse gas emission reductions by using all electric systems. So if you want to achieve the LEED O&M V4.1 and soon LEED V5 rating, by going all electric and looking at that annual energy consumption and documenting it and reporting it in something like Portfolio Manager or ARC, again, you'll be able to get that data. And then lastly, you have to train the occupants of the home under the prerequisite energy and atmosphere education of the owner. You have to train the building manager, and you have to give them an instruction manual on how to operate the home. So what's going to be different in an electric home? How do you maintain heat pumps versus methane gas furnaces and air conditioning? Stoves, electric stoves are easier to clean than coiled stoves, because gas stoves typically are harder to clean because they have all those indentures in them. Servicing refrigerant lines, who's doing that? Filters on mini splits need to be changed, just like a furnace filter, or washed. Cleaning condensers in condensing dryers, very concerning. Gas leak testing, right? Ongoing gas leak testing doesn't need to happen. Think about it. What are some other maintenance issues, opportunities, or drawbacks that would happen when you're looking at an electric home? Those need to be in your training for your occupants, your tenants, and they need to be embedded in the home instruction manual per LEED energy and atmosphere education of the homeowner. The other prerequisite we're looking at is materials and resources durability management. And again, if you're using heat pump technology or condensing electric dryers, you're eliminating that vent, which has lots of benefits, from air leakage reduction to pest entry to maintenance, but you're exchanging it for maintenance that needs to occur on a drain line, and a drain line coming from the dryer as well, and making sure that's maintained. But one of the requirements of the MR durability management is making sure that you have proper exhaust for your drier. And so you eliminate that need for proper exhaust, and that's an automatic, you get that part of the prerequisite just by going condensing, which is typically, again, condensing dryers are typically electric or heat pump technology. All right, well, hang with me just a little bit here. Wrapping up, we're almost done. Lastly, we have a credit for innovation in green vehicles. And so that's not just all electric vehicles, but it is heading in that direction, especially under V4.1. And so again, by having electric car charging stations and incentives for electric cars, and electric car charging within the garage, and electric car charging access to tenants who can use it on multifamily, there are additional points. And so again, that should be part of the conversation when you're talking about an all-electric project. Typically that delves into getting the electrician involved. And sometimes it just means pre-wiring for these systems so that, the new homeowner can decide if they want to install it and use Inflation Reduction Act rebates to do that. But in most, in other cases, you want to install those. And if they're installed, you can get that innovation credit for doing that. And then lastly, under the LEED environmental quality contaminant control option for air testing, there's a lot going on in this credit. But what we know is that all electric buildings are going to have reduced particulate matter, which comes from burning fossil gas, and reduced carbon monoxide. So this is low-level carbon monoxide. Now, also, these things are coming in from the outside. So there's a whole other aspect of this equation, stopping these things from coming in, especially from urban zones and non-attainment zones. But these things are also generated on the inside, and the two work together when you're talking about methane gas and propane gas powered buildings with those kinds of devices. So by eliminating those, you're also setting the client up to have better air quality. And if you're doing proper air testing of the project, you could get additional point on that through the contaminant control, and you'll have more success, perhaps reduced emissions of these particular contaminants. So what's the future? LEED V5, it's coming out. And just in a quick reading, they don't use the exact words electrification. Some people don't even use that word anymore. Some people use the word zero emission appliances, maybe for political reasons. Whatever you want to call it, electrification, to me, I'm reading between the lines here when I look at the new LEED V5 program that's coming. So operational carbon wants to reduce refrigerants. So again, when you're going all electric, you have more refrigerants to deal with. So that can be a problem for global warming potential. So that's something to consider when you're going all electric. What are the refrigerants being used? Ideally, we want to use CO2 as the refrigerant because it's neutral. It's carbon emission, embodied carbon of 1. And then transportation, right? So again, the electrification of the vehicles moving to and from that building is going to be looked at heavily. And then here they're talking about rewarding credits for ultra low carbon emissions in the operation stage for O&M and ultra low greenhouse gas emissions for new construction. There's really no way to get to ultra low greenhouse gas emissions by burning fossil gas on site. It just isn't possible. So electrification, if not outright mandated, is going to be nearly unavoidable, I believe, under the new version of LEED that is rapidly coming. And that comes into health, as we just mentioned in the air quality testing. They're going to be requiring ongoing measurement of indoor air quality to continue to maintain the operation and maintenance LEED rating. And so that's important, again, by reducing those emissions, as we talked about, to continue to maintain that LEED V5 rating. All right, so that is the end of this section here, Succeed with LEED series for electrification. We're recording this entire series and listing it up on our USGBC channel and on our YouTube channel. So you'll be able to watch that and access all of these as we put more out. For those of you watching this on demand, you got to take your quiz with an 80% passing rate, and you will receive your continuing ed certificate. For those of you watching this in the future, watching this now, check your spam for certs at gutenbergcerts.com, and you can receive your certificate that way. And as always, we just want to say a huge thanks to our volunteers, our board of directors, our executive director, Jose Reyna, and all of our sponsors, especially our top tier sponsors, Rheem and Mitsubishi, who have products who are helping advance electrification. And we're seeing their products being used quite a bit in LEED electric project, all electric projects to achieve those goals. So before we wrap up, I can hang out a little bit longer to take any kind of questions. For those of you watching the recording of this, we always try to answer the questions. So put them into the comments, the chat, wherever. We always like to respond back and answer your questions anytime. So I'd love to have some discussion and stick around a little bit longer if you'd like. Otherwise, thank you again. And we hope that you will be successful, whether you're doing LEED or whatever work you're doing out there.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.